Hey guys, this is Miss Avejan. Today in this video we're going to talk about energy. We all use energy to move, to play, to cook our food, but do we know what it really is? Think about it. If you had to define energy, what would you say? Stop the video for a moment and write down your own definition of energy. Some of you may have included movement, or the ability to move, or even heat. All of these are forms of energy. Other forms of energy include waves, like electromagnetic waves of visible light, X-rays, microwaves, or the sun. Also chemical, like for example, bonds that are forming. Electrical, like in electricity. And one very interesting type of energy is sound. Let's watch what sound can do in this video. Is it possible to break glass just with the sound of your voice? Yes, you don't even have to do it for a long time or to have a very strong voice. All you have to do is break the particles in the correct way. There are two forms of energy that I hope you're very familiar with. One of them is kinetic energy, the energy due to motion, and we can see it in objects that are moving. And the other one is potential energy, the energy due to position. Here we can see that this has the potential to do a lot of harm. It's just waiting there. This type of potential that some objects have due to their position is called potential energy. Other examples can be, for example, the potential of a ball to fall, or the potential that you have when you reach the top of a roller coaster ride and you're about to go down. Scientists now understand energy as the ability to cause change. If you think about it, every other type of energy has in some way the ability to cause change. Remember, energy doesn't disappear. The law of conservation of energy states that energy cannot disappear, cannot be created. Energy can only be transformed. It can only change from one state to another. We now know that energy flows from hot to cold objects. Look at this example. If you hold in your hands an ice cube, the energy of your hands is going to cause the ice cube to melt. Energy is passing from your hands, which are hot, to the ice cube, which is cold, causing it to melt. Thinking about energy changing state, how do you think that energy would move from these objects in these situations? If object 1 was an ice cube and object 2 was a glass of water, would energy move to the right or to the left? If object 1 is your hands and object 2 is a hot chocolate drink, if object 1 is fire and object 2 is marshmallows? Yes, you are correct. We understand heat as energy in transfer from objects of higher temperature to objects at lower temperature, or heat as the transfer of hot to cold. Heat can be transferred in 3 ways. Now here's a chance for you to get a ticket if you remember which are the 3 ways. So stop the video for a moment and see if you can remember the 3 ways in which heat can be transferred. Let's start by talking about radiation. Radiation is the transfer of heat by waves, for example, from the sun, from a microwave. Convection is the heat transferred by masses of molecules that move by different densities. Let me show you with a video. Many of you might have seen lava lamps before, but do you know how they really work? The heat is on the bottom of the lava lamp, which is going to heat up the water and the particles of oil that are floating in the lava lamp. So the particles of oil that are very heated up are going to lose density and they're going to be moving to the top of the lava lamp. As they reach the top of the lava lamp, they start to cool and get colder, and so they start falling down, reaching again the hot surface, then heating up again and going up to the top and down to the bottom in consecutive ways. The last type of transfer of heat that we will study is conduction, which is heat transferred by direct contact. For example, materials that are good at transferring heat, we know them as conductors. Some of them can be metals. Other materials are very bad at transferring heat, and so we know them as poor conductors, and we call them insulators. You may have figured out that some good insulators are wood and foam, and also plastic. We can measure heat using calories or joules. Let's talk about calories first. A calorie is the amount of energy that it would take to raise the temperature of this milliliter of water by, say, heating it up to 1 degree centigrade. This we call it by a calorie with a lowercase c. What do you mean? Well, in our bodies, we burn food. That's the job of our stomach, but they do it in a very slow process that is safe for us. We estimate the work that our cells are taking to accomplish the breakup of food into nutrients by using a measurement of heat like calories. But actually, there's more. This is calories with a lowercase c. But the one that we actually use when we talk about the amount of calories that are in a hamburger, for example, are calories with an uppercase C. Calories with an uppercase C are known as kilocalories, and they are the amount of energy that is needed to raise the temperature of 1 liter of water by 1 degree Celsius. Just so that you understand, to get rid of, say, 1 kilogram of fat, you would have to burn 7,000 calories, which would be around 7 liters of water, and you would have to burn it so that all of these 7 liters would increase by 1 degree Celsius. That's a lot of calories and a lot of heat. Some food that we eat are more difficult for us to digest, and so they burn more calories than others. Examples of food that burn more calories include spicy food, whole grains, like fibers, and include, for example, nuts. We also measure heat using joules, which we will study later in the class. But just so that you have an idea, there are 4.18 calories in a joule. Notice that these are calories with a lowercase c. This concludes the end of our energy unit. Thank you for watching and have a great day.